All right. Welcome to the ASP.NET Community Stand-Up. I'm excited we'll be talking today about minimal APIs, which is really fun. I'm John Galloway. I'm a PM on the .NET community team. And today we have with us Safia and Stefan. So can you folks introduce yourselves?
Yeah.
Sure. Stefan, you want to take it away?
Thanks. Yeah, I'm Stefan Halter. I've been on the ASP.NET team for a while. Before, I've worked like a lot of Kestrel and SignalR. You might see me doing some of that stuff. And then recently in .NET 6, I've been working a lot on minimal APIs. And Safia?
Nice. Yeah, I'm Safia. I've been hanging around these community stand-ups for a while. I was previously working primarily on Blazor, but I've made a slight shift and I'm now working on web frameworks, which includes, amongst other things, minimal APIs with Stefan, and we're here to talk to you about that today.
Awesome. Okay. Well, as we always do, we start with the community links, so let me dig into those. It's nice to see all the comments in the chat from everyone, including this Damien guy. Nice to see Damien.
Yeah, who is he?
Who's he?
Yeah, exactly. Yeah. All right, let's go with this. So here we go with our community links. This is the list I'll be running through. So first of all, just want to put a plug out there for on Thursday, the 27th, we've got a Let's Learn event with modernization. And part of why I bring this up is because we'll be covering ASP.NET modernization as well. So this is covering moving from ASP.NET running on Framework, as well as WinForms and WPF, and modernizing to running on .NET Core. So very cool stuff. And this is totally a self-serving plug here, but we created a module here, a learning module that goes through using the Upgrade Assistant to upgrade an existing MVC4 app from Framework to Core. So, all right, got a few friends pinging me about new books coming out, which is exciting. So these are different updates. I always am like, I struggle with, like there's a ton of books out there and I don't want to play favorites or whatever, but I am excited about this. First of all, Jürgen's book is really cool on customizing ASP.NET Core, and it's updated now, including minimal APIs. So that is very cool. And it covers a lot of like in-depth kind of, customizing like, endpoints and action filters and some of those kind of more in-depth things that you might do. So a few others that I'm excited about. There's Anthony Giretti's beginning gRPC, also updated with ASP.NET Core 6. And this covers all the, ASP.NET Core Razor pages, etc. And then one other one, Sean and team have updated or have just published their pro microservices for .NET 6. I've been in contact with Sean over the course of writing this book. He runs the Tulsa.NET user group and active in that community, and he's been busy with writing this book. So exciting to see that come out. All right, just a few others here. John Hilton talking about using Tailwind JIT mode when developing Blazor apps. So Tailwind, my understanding, I'm not an expert on Tailwind other than I know you don't insult Tailwind developers. They freak out. But Tailwind can optimize things based on using some, like, it doesn't do things at runtime. It'll do things at compilation time. However, if you're doing local development and you want to have the reload and all that, then you do want to use JIT mode. And so this talks about how to set that up. So installing using Tailwind 3, using Tailwind extensions for ASP.NET Core, and then configuring that. So good stuff. All right. Here's a post on OpenTelemetry and .NET. What I like about this is just kind of a high level. We've done some shows on OpenTelemetry, but this is kind of a nice kind of getting started, how it's used. And then another nice thing I like to see is the sample here is written with the modern minimal style. So cool to see that. All right. Here's a nice intro level course by Matthew Jones, and this is on dependency injection in .NET 6. So, this is if you're kind of new to dependency injection, if you're just kind of learning the terms and want to see how it's implemented in .NET 6, it walks through there. So, so just kind of nice, useful, kind of getting started, reviewing terms, talking about scopes and things like that. All right, getting towards the end here. So Jiri here is covering a simple WebSocket client and server using .NET 6. And this, again, this is neat using this, very minimal code here. So this is just a few lines of code and we've got a WebSocket server. So this is neat to see.
I'm obsessed with how much top-level programs make everything look so simple and beautiful. I was like, whoa, that's not that many lines of code. It's so straightforward and easy to grok.
It, like that, and then also like the name, like here you don't even need a namespace, but like the
yes,
file level namespaces and stuff like that is very cool. So.
Right, and this is what Signalar is doing under the covers, but you don't have to hide it behind a bunch of dependency injected services and so forth.
Yeah, exactly. All right, then here's just a few other minimal API things I wanted to call out here. So we have a learning path on creating web apps using end services with minimal APIs. So this covers 3 things. One is just building kind of a hello world. Then we go through and add in a database. And then there's actually creating full stack applications using React. So that's kind of cool. And last then, just a few others that the team here passed on to me as we were getting ready for the show. This is a gist by David Fowler, just with a bunch of notes on minimal APIs. Take a look at this scroll bar. There's a lot of information here. So, and I assume you'll be covering some of these scenarios here, but it's nice to have this kind of more with code samples here.
Yeah, this is kind of everything that is currently supported, or most everything that's currently supported. And Stefan and I are going to be adding color to a lot of the content you see covered here in our presentation.
All right.
I like to think of it as a cheat sheet.
Oh, go ahead.
Like,
yeah.
You can just see a bunch of examples, like who reads the prose, right? You just look for the example that does the thing most similar to what you want. You copy and paste and edit it till it works. I think a lot of people's workflow.
Yeah, exactly. This is the Stack Overflow cookbook style, right? It's like, how do I do this one thing? Logging, great, here it is. And then the one other thing that you pointed me to that I had forgotten about, this is the minimal API docs. So this is spelled out here in the actual kind of Microsoft docs. And I am done talking. I'm ready to have my mind blown with some more minimal API stuff.
All righty. All right, I think you can just switch over to my screen.
All right.
And
For those watching, we are doing a rendition of our .NET Conf talk. Our .NET Conf talk was only about 30 minutes. We've got an hour here today to bore you with all of the excruciating details about minimal APIs. I'm just kidding, but we're going to kind of get a little bit more into the hood, under the hood with everything, and Stefan's going to start that off. So hopefully if you've had any lingering questions from the .NET Conf presentation, or you just love the in-depth material, this is for you.
And we'll be taking questions too. That's another nice kind of difference between .NET Conf, is we actually have time for some questions here.
Yeah,
right.
Thanks for the intro. And absolutely, if you guys have already seen the .NET Conf presentation, this will go over that a bit. But like Safia said, we'll get more in depth and, insert your questions now if you didn't get a chance to get your question answered last time. So
can we actually, sorry, but just one thing here. We do have a question that I do think is worth calling out, just like right at the beginning to get started. So what do we mean when we say minimal APIs?
Wow, isn't that a great question? So basically, we made several changes to how you can define APIs with less boilerplate, kind of get straight to the business logic in .NET 6. And there are kind of two major categories of minimal APIs, which I think confuses people to an extent. First is the new hosting model. So all the new ASP.NET Core templates use web application or web application builder, as opposed to what we called the generic host before, or the web host. That is a minimal API, and that's something that we'll talk about as part of this. The other thing that was introduced in .NET 6 was new overloads to like map get, map post, all of that, which act more like the callbacks that you pass to map post, map get, instead of always being a request delegate, which take an HTTP context and return a task, are more like MVC controller actions. So you can get parameter binding, results types, and we will go into that in much more detail as part of this demo. But I would say those are the two major categories: is the new host, web application, and the new way to define route handlers is what we're calling that.
And I will add to that and say that we don't intend for minimal APIs to replace MVC. They can kind of coexist together. You can experiment with using minimal APIs for any new web applications that you're looking to build. And actually part of our work in .NET 7 is bringing a lot of the functionality that is an MVC over to the minimal framework, so that you kind of have a lot more parity there. But the idea is that I like to think of it as less of a versus and more of an and we're giving you more choice with respect to which technology you want to use based on the particular problem you're looking to solve.
Yeah, that's an excellent point. And to add to that, minimal APIs don't have all the same features as MVC controllers. They have some similar concepts, but controllers certainly have more features as far as like action filtering and things of that nature. So there's more extensibility in the MVC model. We're looking at adding some of that extensibility back to minimal, but we're also trying to keep high performance. So maybe after we're done with this demo, we can actually look at MVC controller versus minimal action performance for like a micro JSON kind of benchmark. It's not super applicable to most web applications that might be doing database transactions or whatever. It won't make a huge difference, but it's kind of nice to know what the overhead is for when you really are trying to do something very simple with an API endpoint. Yeah. So without further ado, kind of the pretext for our .NET conference demo is that we're software developers working for Contoso Construction. You might have heard of Contoso before if you've ever seen Microsoft docs or demos. And Contoso Construction is managing construction jobs geographically, and I am writing the backend microservice for that. and then Safia is going to add to the backend service and then add a front end a little bit later. So we've already written this application in .NET 5. So that's what you're seeing in this generic host MVC server project. So this is your typical generic host, right? So that's host, create default builder, configure app configuration, use a startup class. This is typically, if you use the templates in .NET 5, the kind of application you would set up with. So just to kind of show people the differences between the hosting model, we're going to try the same thing with web application to see how this works. So all of the new MVC, ASP.NET templates, including the MVC template, use web application builder in .NET 6. So if we do a new minimal server .NET 6 ASP.NET Core empty web app, we should see something pretty small. So this is taking advantage of, I did not do the empty one. So let's delete that really quick. Make sure that doesn't get in the way. All right, and then we'll do this one more time. Let's just do it over here. So that one was using controllers. The template I just created was using a controller, API controller with the web application or web application builder, which is something you can do, right? So as you're talking about how minimal APIs kind of encompass two major concepts, like the new host and the new way to define endpoints, you can mix and match. So you can use this web application builder and then call, add controllers, call map controllers, all of that, just like you would with the generic host. And if you want to do that, you can use that template that I just created, which was the controller template, and you'll still get the advantage of the new host. But for now, we're trying to go like all in. We're trying to move away from controllers and see if we can just do this using the new, map get, map post overloads. So one of the first things this did was set up our database configuration. It read the keys from Azure Key Vault, and then later it configured the EF framework, connection string for SQL Server, all of that in two separate files. It was like one to set up the configuration of the host, and then later we set up the service configuration in Startup. So now this can all be done in the same file. So we can start by adding the Key Vault stuff. This is going to complain because I don't have the Azure Key Vault dependency. So really quickly, I'm just going to copy those dependencies. So one thing that you'll notice in the new CS proj is that we're using, and I mean, you will also notice by just looking at program.cs, is that we're using top level statements and implicit usings, which are new features in C# 10. At least the default implicit global using. So this means that everything after the usings basically is implicitly part of program main. And a lot of...
Can you bump up the font size just one click?
Absolutely.
Thanks.
Yep. So basically all this code is part of program main. You have this magic args variable. A lot of you probably have seen this already. But now all of our templates are using this, smaller, less boilerplate model. Another thing that's notable is that this configuration type right here, in the past inside of program, you would have a configuration builder, which you would add configuration to. And then there would be like multiple stages of configuration. So if the Vault URI was passed via like a command line parameter or an environment variable, you could read that out of like the host builder context, and then you'd have like chained layers of configuration. And you basically, had like, it was confusing. So for example, this host, right, has configure app configuration, which we're using here. It also has configure host configuration, which takes just an iConfiguration builder without a context. And that's what sets up this configuration right here. But this kind of multi-stage configuration, while it was useful if you wanted to, say, read a vault URI from an environment variable to then pull in more secrets as configuration, is somewhat simplified here in this configuration manager type. So configuration manager is new in .NET 6. It's exposed on the web application builder .configuration, and it's both an iConfiguration builder that you can add sources to and an iConfiguration root that you can read from. So in this example, like as soon as we add Azure Key Vault, we can read from it immediately if we so wanted. So we could do like builder.configuration, like my secret from Key Vault or whatever, and it will be read. So at this point, we're going to want to set up the EF server with this. So we're going to set up the same job and job site DB that we did in our .NET 5 project. So we're going to define the jobs. So this is exactly the same as before. We have our, DTO, or actually this is just our model, and our DB context. And then we can add that to the service provider using builder.services. So in the past, you would use something like builder.configureServices or startup the startup configure services method. But now we can basically use the iService collection that's accessible directly on the builder to set up services and use that builder.configuration to read the Azure SQL connection string, which just came from the Vault URI.
Okay. One question here, and we're already seeing some questions about style in general and code organization, but in this case, you posted or you pasted your job and your other kind of data classes directly into your program CS, but there's no reason you couldn't put these in another file as well, right? I mean, it's
absolutely. And like one thing to note is that you have to like put these at the bottom of a top level program, which confuses some people. So like if you were to try to put this before app.run somewhere, it would be like defining types in the middle of your program main. C# doesn't like that. So you'll get a complaint saying top level statements must precede type declarations. But yeah, let's actually do that. We can just copy these straight over here. It's possible that I'll need to add a using or something because I'm not sure what namespace this is in. But yeah, we can play around with that. Yeah, so here we can just use the same namespace we did before. And yeah, things will continue to work. So yeah, if you prefer the style of not having everything in one file, that's great. Like eventually, like you don't want program CS to be the entire source code of your applications if it's thousands of lines long. And like Safia was pointing out earlier, one nice thing about web application is that when you are showing samples, like that WebSocket sample earlier, you can kind of show there are no hidden tricks up my sleeve. Like literally all the code and the sample is in a single file. So I think it's helpful in a lot of scenarios to put all your types in a single file, especially when you're like showing it in a GitHub issue or a Stack Overflow post to be like, this really is my entire application. But it also demos well sometimes to be like, oh man, the entire application is like 50 lines of code. But for bigger apps, yeah, it totally makes sense. So now that we set up the services, so we can manage our database, which is SQL Server, let's define some of our endpoints that were previously defined in this jobs controller in the .NET 5 application. So here we have the ability to get all the jobs, post jobs, get jobs by ID, and search jobs by name. So really quickly, we're just going to look how this compares if you're using like the new map get map post overloads. So if we go back to program CS, we'll keep this hello. Let's make sure actually before I get like further along that this application starts up. So I'm going to set this as my startup project. And we'll run this and we'll make sure we still get a hello world. So See, this is why we do this. See,
Yeah.
this is what happens when we go off script, right?
There you go.
Yeah, since I put this in another file, it's like no longer finding the job because apparently I didn't copy it. Maybe that will help. All right. And then, yeah, that's another project, but I'll just delete that for now. It's showing how there are multiple configurations before with the generic host thing. All right, let's try again. You can tell I was at a different DPI earlier. All right. So here's something that I kind of want feedback on. For those of you who have started using .NET 6, how do you all feel about like the new port numbers? It's consistent once you create a template. So it's always the same. Every time we hit F5, we should be on 7106. But it used to always be 5000, 5001. So the new coolness is you create a new project and you don't have to change the ports. If you create a bunch of web projects, they shouldn't port conflict. Are people a fan?
A few things. Yeah. Go ahead.
No, I was gonna say I'm a little bit of a fan of it because I'm kind of a chaotic person and I work on like 10 things at the same time and have lots of projects running. But it did break Blazor WebAssembly debugging in the VS Code extension, so I'm not a fan of it for that reason.
Oh no!
For most other scenarios, I like it.
So hopefully the VS Code extension can be updated to look at launch settings, which is where this is coming from. So hopefully.
Yep. So actually the weird hack that a lot of things use, and this is probably going to make some people cringe, is it will actually parse the standard out from running .NET Run, where it says now listening on blah, 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 to get the port that the application is running on. You might see that in, if you ever use VS Code and you configure debugging for web applications, you'll see it's got a regular expression for parsing out the port from that now listening on.
It would seem like that's something that would be available by API. Like you could ping, I don't know.
Yeah, you could read it from the JSON file or something.
Yeah.
My personal thing is I do like it because a lot of times if you're building a non-trivial app, you're going to have to go through and set up different ports anyways for different APIs and different things. It also, like, there were cases with, I think it's Air Server on a Mac will connect to port 5000 by default now, or we'll take that port. And so I've seen people run into that issue on Mac. But my one negative thing is I have to go and update docs that I've worked on. Because it's like, oh no, screenshots. Oh man.
Like all good things in life, it requires some adjustment.
Yeah.
Yeah. So you're mentioning there being an API like to get what address you're listening on. It exists if you're in process. So if you're like using HTTP sys server or Kestrel, you can get the list of addresses you're listening on from the iServer. Doing something like that. Out of process, I think you're stuck reading the launch settings.json or something. Or maybe if you're like really advanced, you could do like LSOF, look for the open file handles for the process. Try to pull the port out that way. But all right. So let's go back to where we were, and we're going to try to add those endpoints that the jobs controller added in the .NET 5 app, but we're going to do it right here in program main. So we're going to do add define endpoints. All right. So I'm not going to type them all out again, but they should be fairly familiar from looking at the jobs controller. So let me use a different mouse that tracks better. All right. So this side-by-side stuff isn't going to work well with this screen resolution, but you'll see since there is no constructor for the job site DB, we are injecting services via the parameter list to the like map get callback here, right? And so this is the service that we added here in add DB context. So this would normally be constructed or injected in a controller, but you can just add this anywhere in the parameter list for this endpoint. So the way parameters get bound in map get now are much more involved than it used to be. It used to be that map-get only took what was called a request delegate, right? So that is the overload that will get used if you basically don't specify any of the types to the parameters to your callback. So if we did some route and then did context and then task.completed task, that is a request delegate. So here, without even specifying a type, C# knows that, hey, we wanted the HTTP context here. And this is what you would have seen going back to, I think, like around .NET 3. So we have like all of these map get, map post, map delete, and they take this request delegate, and it's this type, right? It's kind of like middleware, but it doesn't take a next function. So it's bound to a specific route. So in .NET 6, what we added, and what are the minimal APIs, are this delegate handler, which a delegate is basically an action or a func of any type. And it really doesn't give any information to the compiler about what the parameter types are or the return types are. The compiler has to look at the Lambda definition or the method group that you pass in. So if you were to define like a local function, so you could do something like, void. So this would be like the equivalent of the hello world, right? That we already have on the endpoint. So here we can do, and so I see my error, by the way, about the return type. But so this is basically, you can pass in either a Lambda or a method name or a local function name, and this should all work. In the past, if you wanted to try something like this with a delegate overload, so like in C#9, you would have had to make this casted, like a func of string, which is why there weren't many APIs like this before. It's pretty ugly, right? So when you're using the new minimal API overloads, you can still take an HTTP context like before, but if you want to take an HTTP context in addition to other parameters, you actually have to put the type name here. So if you like leave out a type name in this parameter list, C# will be like, I have no idea what this second parameter is supposed to be. This doesn't look like a request delegate. So let's talk about like what these parameters can be, right? So if you don't like the inference, right? So in this case, minimal API knows that job site DB is in your service collection. So since you're taking that as a parameter, it pulls it out of the service collection. Usually the inference works really well, but you can also use another C# feature that's new in C#10, which is attributes for lambdas. So this is like right here, you can use attributes, and these are the same attributes you have in MVC. And you can use those attributes in your parameter list for your Lambda. You can also attribute the Lambda itself. So you could do like authorize attribute and that kind of stuff, and it will work. Assuming that you have auth set up and so forth. But it would work in a similar way to applying the authorize attribute on MVC controller. So so in this case, right, we have like a specific from services. If I were to remove it, like this still works because minimal knows job site DB is from the service collection, just like I did before. In addition to taking like an HTTP context, you can take like an HTTP request and response directly. That's what this is showing right here. So let's just like look at this get jobs working really quickly, and we can go over exactly what's happening here. So we're gonna run this command. So this is connecting to a SQL Server in Azure with that Azure Key Vault secret. So we should be able to get some results. clear? Yes. So if we call get on the jobs endpoint, we should see a bunch of construction sites here. So you'll notice that even though I said nothing about the content type of this response, we're getting JSON. So we do automatically set the content type on the response, but like the request isn't requesting any specific content type. This is not content negotiation. If you return a plain old C# object here, so like a task of list of job, which this does, it will always get JSON serialized. So there's this other concept, which is called IResult, which is a lot like action results in MVC, which allow you to have more control over the response without having to call APIs on HTTP response directly. So like here, if instead of wanting to set response.set go 201 and headers location jobs job ID, I could instead return results dot created, which is 201, and then at this point pass in a location. So like it would be exactly the same as that. And then this would have to be right. And now like that response parameter is probably unnecessary, and created requires you to pass an object. We're considering changing that in .NET 7. All right, so there are a bunch of built-in response types for various status codes. There's also things like results.json. So this is very similar to results.ok. When you pass in an object, it will just get JSON serialized. And what you'll notice is if we look at the type this is returned, these are all IResults. IResults actually look a lot like that request delegate type we were talking about directly. So you can define, if you want, your own results types. So I'm going to like skip ahead.
That would be similar to the like I've seen like for specific file type results or that sort of thing. Is that what you're talking?
Exactly. So these methods right here on this results type, which is just a static class, are heavily inspired from MVC action results and are generally aligned with the methods you would see in the controller base class. So if you inherit from controller, you'll often have these as methods in the base class that you just call. And here you can do results dot. Originally, when we were designing this, we were considering doing something like a static using. So we just like include all of these methods in scope. So instead of calling results.created, you would just call created, and then it would search in the results type. And I think it's like static using Microsoft something. And that would work. But we didn't want to include like a bunch of methods in the state in the global scope. So really quickly to show like what that could look like, let's do.
And then after this, we've got some questions stacking up, so maybe we can take a few of those.
We will, and I'm taking a little too much advantage of the extra time we have. So I'm trying to move along a little bit. So here's a custom IResult, which is using XML serializer. So this defines that execute async method, writes it as XML. I spelled better wrong in my snippet. So one thing this is doing is this is buffering everything in memory as opposed to writing to a stream. This is just because of the way the XML serializer works. There's no like serialize async that takes a stream. Normally that would be the way you'd want to do that, is like serialize async to HTTP context.response.body. But here we buffer everything in memory. This isn't terrible as long as you pool. But in this case, we're doing up a memory stream every time, so it doesn't. So don't do this if performance is a huge concern. So you could basically use this by just calling new XML result and then we can do like list of job and return that. And that should compile. But like one thing that's annoying about that is it's not very discoverable, and you end up having to pass all these like generic parameter arguments. So one thing that we also did is we added this IResult extensions type, which is just effectively an empty marker interface. So there's no members on the interface, but what it is basically implemented by a property on results. So we completely ignore the object without any members. But this allows us to basically add our XML method to results.extension. So the equivalent of doing that, which I have right here, would be calling results.extensions.xml. And then because the way C# works, if the generic method arguments can be inferred, they can be omitted, unlike with constructors. So if we try that really quickly, we should be able to make that same type of request, but this time get a bunch of XML once it gets started. Let's take, it might have just taken a second to start up, yeah. So you gotta remember it's connecting to a database in Azure, so that affects the startup time a little bit. Yeah, so then you can do some XML. So the other thing that can be customized is these parameters. So if you take a look at that docs article that you showed earlier, John, which is the new minimal API docs, it goes through parameter binding inference. So generally, the way it works is if you're not using these MVC attributes to specifically say something's like from the body or like from the route. So, I mean, there are attributes for every single one of these. It will assume that if you have a parameter that matches the name of a route slug or whatever, that you're binding from that. And otherwise, it's using a try parse method to figure out the type. So like int has try parse. So this comes in as a string, this ID. But since I'm taking it as an int, we pass that string in and call try parse. You can do that with custom types. So try parse is like a static method you've probably seen on a bunch of numeric types. So if we do something like that, say we wanted to search by latitude and longitude, this is C# record, right? You can define your own try parse method, which takes a string as input and then returns its own type as output. And then all this is doing, right, is taking the string, splitting it into by the comma, and then parsing both doubles as latitude and longitude. So this is a new way we could search, for example. So if we want to find coordinate endpoint, here the coordinate is part of the route just like ID was earlier, but since the parameter type is coordinate instead of int, instead of calling int.tryparse, it's going to call coordinate.tryparse on this. So this is basically expecting comma separated doubles. So one thing about hot reload with minimal APIs is it doesn't really work, especially when you're adding new endpoints, because you have to rerun program main to basically have map get called with this new route. So we're going to restart that. And note, this is still just returning a plain old object. So since I'm not using like results.xml, this will still stay JSON. So in this case, if I wanted to get search, location, and in the .NET Conf demo, I completely forgot what the actual coordinates I should use are, but I think like 47, -122. I can actually look at the results above, see if it gives me anything. Yeah, so it'll give me some Seattle area job sites. And as you can see, like this string is what's being parsed right here. So if I were to like add a breakpoint right here, just kind of prove that that's being hit, I can hit that endpoint again, and you can just see like that. I'm not sure how zoomed in we are here, but right, like that's just the string, and we're just parsing that. All right. So this is one way to influence parameter binding, but that only works if the parameter you're reading is coming in as a string. So basically that means it's either from the route, the query string, or a header. So we know which string to put in the input. So if you want to read a parameter from the body, or if you basically want to have control like of where I'm reading the input from, right? So it's like anywhere other than the string input from a query string, route parameter, or a header. There's another basically method that you can implement instead of try parse, and it's called bind async. So we wanted this to be async, so we didn't have to basically block reading a request body, right? Because in ASP.NET, just because your middleware has been invoked, just because your route handler has been invoked, doesn't mean that the entire request body has necessarily been read yet, unless you had a from body parameter, in which case it is. And like one thing we kind of glossed over is basically from body is like the default parameter type. So for like any kind of complex object that isn't a service, we assume that we're going to read it as JSON from the body. That's unless the type implements this bind async method, which again returns this. So if a type implements both try parse and bind async, ASP.NET Core will prefer bind async. So I've already used a lot of my time. I think if there are any quick questions, I can answer that right now. But otherwise, I think this would be a good time to move on.
Yeah. Okay. So we'll go to some questions. One thing I just want to kind of sum up what I took away, you can correct me if I got it wrong, is you've shown like simple converting in the previous, like the previous standard to minimal API. And then you've shown pulling in, like connecting to a database, like configuring that and showing how you can include those classes in here. And then you showed a lot of the routing configuration that you can do, both customizing binding and then also, like both input and output, right? So customizing what you're receiving and also how you're returning that. So.
Yep. Yeah, and as you can see, like these are all based on like the types in your parameter list and the type that you return. So unlike MVC, there is no like currently there's no action invocation pipeline where you can be like for all actions, like no matter what their parameter types or return types, like run this logic. You can of course still write normal middleware, but there's no like, oh, here are like the list of objects which are going to be my parameters that I can edit like in a pipeline. The big reason for that is performance. So it's all based on types. So it's the IResult type you return or static methods on the types that you take as parameters.
Okay. And this is all like obvious in the name, but this is all keyed mostly towards APIs, right? So these are core things you're going to do. Like part of my brain jumps to MVC and like web stuff, but here there's no HTML involved here. This is API focused.
Yeah, so the focus is API. Now, nothing's stopping you from creating like an HTML IResult that does some crazy templating and sets, text HTML content type and all of that. But we don't ship that. And there are some things that aren't as easy. For example, reading form inputs, at least for now, you have to do manually using like the HTTP request or HTTP context. We don't want to make it too easy to read form variables without anti-forgery story. So that's part of the reason there.
Got it. Cool. All right, let's run through some of these questions here, and let me see. Some of these I think were covered along the way, but possible to pass a parameter to a post request. Yeah, I think we covered those. Yeah. So cool.
Yeah. So if we want, we can just test that out really quick. If this was running, but anyway, in theory you could.
Okay.
But Safia, let's move on. The server wasn't running at the time.
Okay, cool. Let me see. Do minimal APIs work with gRPC?
Nope.
Yes, so they're they can coexist. It's not so minimal APIs is building for API based services or HTTP based API services. gRPC is an RPC based protocol. If you want to build an app that has both, you can. gRPC basically requires that you add some services to your DI. And then there's a map gRPC service extension method that you invoke on your web application that registers a gRPC service into the routing pipeline. So, you have a web application that can host both minimal endpoints and gRPC services within the routing pipeline. And actually, if you try the new gRPC templates in .NET 6, you'll see an example where you have a gRPC service and an endpoint, a minimal endpoint in one application.
Okay.
Yeah, great catch, Safia. It's kind of like I was talking about earlier, how the split between minimal APIs being the new web application and minimal APIs being these new map methods can cause some confusion. So anything that you could do with the generic host, you should be able to do with web application. So that's why all the new templates use web application.
Okay. Several comments in one kind of topic. I'll just kind of run through them all together. I'll throw all the questions at you and then you folks can jump in. But so Brave Cobra had a few kind of comments on why make the templates kind of the default. And for more of the, for like an enterprise application, it's hard to kind of scale up. And then some kind of, like Nasar also saying, is this just for medium or small projects? Can it scale? And then finally, talking about templates in general, you can still, like one workaround, if you do want to use the, more structured style, you can use the .NET 5 templates and then upgrade. But it's, so I guess what are the thoughts on, if you're creating a larger API, is this still kind of the way? And what if, for folks that do kind of want that more kind of structured feel?
Yeah, so I think you have a lot of options. So yes, this allows you to put a lot of code into your program.cs, and certainly for demos and like bug reports, a lot of people do to show that there's like nothing up their sleeve. But what I might suggest doing is, you can add classes, right? So you can do add class and be like, I'm going to add my jobs endpoints, right? And then I can just make this static. And then I can do like void add endpoints. And then this can take an endpoint builder. And then all that code that was in program CS, right? I'll even add the hello world endpoint. All right, apparently I failed to copy unless, there we go. Yeah, so you could basically, I have to fix up my namespaces and all that, right? But then once you do that, you can just do, jobs, endpoints, etc.
And just call them
add endpoints, etc. So I'm not sure why that's not in scope I think it's because I called it jobs endpoints instead of job endpoints or something like that. But yeah, that's the idea.
Okay.
Yeah. So yeah, you could do that and then so on and so forth. Add endpoint, pass an app.
I do almost wonder about like creating some like, Rosalind refactorings that could make it easier to do some of these. Like if you do, because I do understand a little bit, like I've worked on some where when you get to the 70, 80 lines of code, then you do want to kind of bring in some more structure. I mean, you can do this manually, but it might be nice to say like move endpoint to, whatever, to another class or something.
Yeah, it would be a nice refactoring. The nice thing is like extract a method. I probably should have used that, to be honest.
Oh, right.
Might have worked pretty well in this case. But yeah, So, I mean, that's the kind of thing that you can do. And then once you have a lot of endpoints, right, you could split that up into different classes or different methods.
Got it. Okay. I'll try and run through a few more questions real quick, and then we'll turn it over to Safia. What is the recommended alternative for action filters with a minimal API?
So this is a great question, near and dear to my heart, because I've actually been working on the design for supporting endpoint filters in .NET 7. There is an issue tracking that on the ASP.NET Core repo if you're interested in learning a little bit more about it. It's going to go through design review this week. So that is something we are planning on adding more functional support for with minimal APIs in .NET 7. That being said, depending on what you are trying to do, you can get away with quite a lot with minimal APIs using endpoint metadata, which we've leveraged quite a bit in our internal implementations as well. And you'll see that when I show some of the stuff around OpenAPI and middlewares. But we are planning on supporting that a little bit more fully as part of .NET 7.
Okay. The auth endpoint you showed, is that the same auth attribute? Is that the same as an MVC or different?
It's the same attribute. Yeah. So all the attributes that we've used so far in minimal actions are the same. We do some trickery in the layering using like marker interfaces to make those interfaces work. So even though like from bodies in the MVC assembly, what minimal APIs is really looking for is this interface, which is defined kind of at a lower level. So yeah, as far as attributes work, it's all the same. Results are different. That uses the new IResult type. If you try to return a minimal IResult from an MVC action or an action result from a minimal route handler, it won't work. We're trying to look into making the errors better there.
Okay. I'll take two more questions real quick. So the try parse that you showed, is that reflection magic under the covers, or is it more of a first-class citizen in .NET? I think what they were showing was like the work you were doing with the try parse on the coordinate and that kind of thing. Is that?
Yeah. So the way this is found is reflection magic. Potentially it could be like Roslyn source gen found as well. This try parse interface happens to match the signature of the try parse method in the new static like iParsable. We have like starting in C#10 is like a preview feature, static abstract interfaces, which are kind of crazy, but basically allows exactly this, where you can put a static method like try parse on an interface. So if you want to implement that, I think it's called iParsable, but you have to opt into the feature, and that will give you some confidence that you're overriding or you're implementing the right method. If you get the signature slightly wrong, you'll get startup errors being like, oh, we saw a try parse method, but didn't have like the right parameter types or whatever.
Okay. One last question, then we'll give Safia some time here. How can minimal API be faster than a controller API? I think this is it. Yeah, so go ahead.
Yeah, so mostly it's because we're not setting up like action invoker context and so forth. Those require allocations. So the extensibility that MVC offers you has a context to work on. But you end up having to like allocate an array for the parameters that are being passed to the action method and so forth. None of that is necessary for minimal APIs. So that's one thing. Yeah, that.
Okay. All right. I guess we'll give. So Safia, did you want to share your screen?
Yes. Let me get started with that. If you all have survived an hour so far, thank you so much for sticking through it. I loved all of the material that Stefan covered. I am going to go in a little bit of a different direction with my portion of the demo. I think everyone can see my screen. I'm going to switch to VS Code so you're not seeing all the StreamYard craziness. So what I wanted to do for my section is go through the exact same application that Stefan demoed and that we used in our .NET Conf presentation, But I also wanted to enlighten everyone a little bit about what's going on behind the scenes from a framework perspective with a lot of what's going on here. So we're going to look at the code that you as a user would see in your application, and then we're kind of going to go behind the scenes and take a look at the framework code behind that and talk a little bit about the concepts and how everything connects. So hopefully that's super informative, and then you all feel empowered to maybe contribute or just understand a little bit more what's going on behind the scenes with all of this fun stuff we got going on. So the first thing that I wanted to start talking about for my section of the presentation was OpenAPI support for minimal API applications. So if you're not familiar with OpenAPI, it's a specification for documenting the shape and structure of RESTful APIs. It allows you to document what kind of request data a particular API takes, and then it allows you to document the responses that. So OpenAPI is that specification. There's an analogous technology or a shared technology in this space called Swagger, and that's kind of the tooling for that specification. So Swagger is going to provide you with tools to generate JSON-based definitions of your OpenAPI. We're going to take a look at what that JSON looks like in just a little bit. It also gives you a UI for browsing through the specification and even executing code. And one of the other concepts that kind of exists in this space and is unique to ASP.NET Core is the idea of the API Explorer. The API Explorer sits in between your minimal API or your MVC application and the open API definitions that are created by all of the things like Swashbuckle and NSWAG that exist in the ecosystem. So we're going to kind of break down all of that stuff by taking a look at user code and kind of getting behind the scenes into the framework. So I've got the same program CS file that Stefan was playing around with. I've made a few modifications to it in order to support being able to generate OpenAPI definitions for my application. So the first thing you'll see here, and hopefully I'm zoomed in. John, you can yell at me if my screen's a little hard to see.
Yep.
Awesome. So first things you see here is that we're invoking this Endpoints API Explorer extension method onto our service collection or into our DI. And what this is basically going to do is it's going to inject a service called the Endpoint Metadata API Description Provider. That sounds like a mouthful. All of our class names tend to be mouthfuls when we're doing things like this. And this is the API Explorer service that's responsible for taking a look at all of the endpoints and route handlers that are registered in your application and identifying what types of parameters they take and what responses they produce. So this is the thing that looks at all your handlers and says, okay, this is taking a jobs object, which references this particular parameter, or this is taking a user claim and kind of ties it all together into our intermediary representations. This other service that we're injecting is provided actually by Swashbuckle. And at SwaggerGen is going to register some services that are responsible for producing the actual JSON representation of the OpenAPI definition. Swashbuckle takes care of this by reading from the API Explorer types that we produce, mapping them to OpenAPI types, and then serializing those OpenAPI types into JSON. So the kind of flow of things is your handlers go to the API Explorer that creates intermediary types representing each handler and its parameters. Swashbuckle takes that and turns it into OpenAPI definitions and then serializes those into JSON. So that's kind of the end-to-end flow for that. And then last but not least is the Swagger UI bit. So you'll notice that I have here conditioned with an is development check. We kind of will register two middlewares that are responsible for serving up the Swagger UI. The Swagger UI, if you're not familiar, is this fun little thing here that allows us to view all of the routes and whatnot that are registered on our application and kind of interact with it. So those are all the services behind the scenes. I think, it's pretty subtle. It's only a few lines of code. What is it, like 1, 2, 4 lines of code? But there's actually a lot of different components coming together to make the end-to-end work, which I think is pretty neat. So how do you as an end user actually use it? If you saw the .NET Conf demo, you might have spotted the fact that we rely pretty heavily on extension methods on your endpoints to annotate a lot of these things. So here we've got our map-get endpoint that will return a list of all of our jobs. And we can write these annotations on our endpoint to identify what types of response it produces. So we could say this is going to produce a list of jobs when there's a 200 status code. And then we can also annotate it with other metadata, like give the endpoint a unique name. Here we're calling it get all jobs. This is actually a really important concept in OpenAPI, this with name thing, because this name acts as what's known as an operation ID for our endpoint. You can basically think of it as a unique identifier for the endpoint that is going to be used in both the UI, the JSON schema that's created for it. That's kind of like the unique identifier for it. And we can also tag our endpoint. So we could say that this map get is one of the getters in our endpoint. We've got the one that gets all jobs, and then we've got another one that gets jobs by ID, and they're both getters. So we can label them that way. And you'll notice if I sneak back into the UI, all of the get related endpoints are categorized in their own area. So let's take a look at this produces extension method. What's that doing behind the scenes? So I'm going to pop over into my other window here. You are now in the ASP.NET Core code base. So this is not our application anymore. This is the extension methods that we have to provide all of these shorthands for annotating your application with OpenAPI. So you might recall that a little bit earlier, there was kind of a question asked about action filters. And one of the things I mentioned is that one of the concepts that we're leaning on heavily and have leaned on heavily for the OpenAPI implementation is the notion of using endpoint metadata to annotate and describe endpoints. And you can see that at play here when we take a look at this produces extension method, which basically says, hey, when I'm invoked, go ahead and add new metadata to this particular endpoint. And this metadata is going to be our produces response type metadata. This is similar to the produces response type attribute that existed in MVC that you can actually still also use in your minimal API applications by doing this, similar to, I think Stefan showed the fact that we can kind of use attributes on our delegates now, which is nifty if you are not a fan of the extension method model. So we're going to annotate our endpoint with this produces response type metadata. And this is actually what our endpoint metadata API description provider, that's that API Explorer component, is going to read from. And Swashbuckle and NSWAG and kind of other tools in the ecosystem can also read from this endpoint metadata to understand a little bit about, what response types the API is producing, or if we take a look at the with name, I think it should be here. Yeah, we've got with tags, which produces a tags metadata, which is actually just a tags attribute. One of the interesting things that we've kind of had to think about a little bit with some of the stuff as we were building it out is some of these types are shared with MVC. So produces response type is also a concept that exists in MVC. I think name is something that exists in MVC. And one of the things that we're kind of thinking about is how do we organize all of these shared types in a way that makes sense so that we can use them in both MVC and this route handler minimal API approach when necessary. So we've got with tags.
The tags, the with tags syntax kind of changed and developed kind of late towards shipping, right? Was that towards the end?
Yes. So with tags came in late towards the end. With name, all of these OpenAPI things, I think we kind of did around like the preview 8 RC1 time span. And one of the things we actually did quite a lot of fiddling with is figuring out what endpoint builder all of these extension methods target. You will notice that they specifically target the route handler builder, which means that you can only use them on map get based handlers. such as this one, map get or map action, I should say, based handlers. That was a kind of decision we were playing around and experimenting with towards the end of .NET 6. And I think actually we're going to keep kind of revisiting this in .NET 7 because we've heard feedback that the fact that this is limited to this particular concrete implementation of the builder is kind of limits the flexibility of the implementation. Okay. But yeah, that's a great point to bring up, John, because I think we've heard a lot of great questions in the chat so far from folks. And we really value that feedback. If you have an idea or if you see something in the API that's like, I feel like this is kind of a little bit constraining, definitely file an issue on GitHub and give us that feedback so we can kind of keep all of that in mind as we refine minimal APIs in .NET 7. Cool. I want to show you a sneak peek of the, or not a sneak peek, I'm going to dive you right into it. We're going deep into the framework of the API description provider that leverages endpoint metadata. It's got a bit of a mouthful name, but it's called Endpoint Metadata API Description Provider if you want to log it down and take a sneak peek at it earlier. So this is actually what's going to run and examine all of the metadata in our application or on our routes and determine what kind of API description needs to be created for it. So the API description type is that kind of shared type I mentioned that tools like Swashbuckle and NSWAG can take a look at and then use to produce the open API definitions. And what this is basically going to do is it's going to examine the method and try and construct a definition of, or examine the endpoint and construct a definition of what HTTP method it references, what the name of the method is. It's also going to try and take a look at all of the parameters defined on the method. So if we go to our jobs by ID endpoint here, it's going to try and take a look at the ID property that's passed and add that as a parameter to our request. If we pop into this method, I want to kind of point out one thing and use it as a segue to dig even deeper into the framework. So one of the things you'll see is that we're taking the parameter info here. So this is the, say, the parameter info associated with this int ID parameter. And one of the things we're going to do is we're going to try and resolve the binding source and the name for that parameter. So, hey, is this a parameter that's going to come to us from the path in the route? Is it going to come from the query as a query parameter? Is it coming in the request body in a header? All of these things. And this is actually the same logic that is used under the hood in what is called the RequestDelegateFactory. It's referenced here in this code comment where we have a to-do that says we want to share more of this logic. Everybody's favorite to-dos is like, this is pending refactor. We should probably be a little bit more dry in how we write this.
It's totally going to happen.
Yes, it's definitely going to happen. Actually, if now that I've kind of dived into this code base, maybe there's like a really intrepid viewer who's going to go in and tackle this issue and help us reconcile some of the shared logic between this API description provider, which is looking at the parameters in the handlers that you write to understand what kind of descriptions it needs to produce for OpenAPI, and the RequestDelegateFactory, which is very intense. I almost feel like I need to zoom out because there's a lot of code in here. But the RequestDelegateFactory, as the name might suggest, is responsible for taking the handler that you give us, which is this thing here, and converting it to a request delegate. There's a lot of expression tree generation here, and the idea is that we're going to do things like examine the arguments that are defined, or examine the parameters that are defined in your method, similar to what we do in the API description provider. So we're going to examine the parameters and use them to bind the arguments or the parameters to the request. So what that ends up looking like is, actually, you'll see it here. So you'll notice that in the endpoint metadata description provider, we do this thing where we say, hey, take a look at the parameters that are, or take a look at the attributes that are in this parameter. And if you know it's an I from route data per attribute, then we know that this particular parameter needs to be bound from the path, and we can pull the name and things like that from the attribute information. The RequestDelegateFactory does something similar. It checks to see, hey, this parameter that's in this handler that the user has given us, does it have an iFromRoute metadata attribute on it? If so, we're going to bind it as a route parameter. And what this is going to do is fill out a lot of funky, sorry, go to definition is not working for me in VS Code, which is a little embarrassing. But it's going to spit out the definitions that are needed to read that parameter from the route. And I will show you that in just a little bit. But you can see it does this for route metadata, query metadata, any situation where you explicitly use an attribute to define that a parameter should be from a particular source. Then there's also some stuff that we resolve implicitly. So for example, if we see that, or we handle HTTP context and all those fun things. But another thing is implicitly, if we see that a parameter type is a string or it's something that has a try parse method, then we'll try to parse it as either a route parameter or a query parameter. So in addition to you being able to explicitly define the binding source for a parameter using attributes, we also have some heuristics that we use to say, hey, if it's parsable, then it's either a route parameter if it's defined in the template, or it's a query parameter. Otherwise, it's probably in the body somewhere. And so all of those rules kind of exist here. There's also some funkiness that we had to deal with for distinguishing between something that is a service that has been injected into your application versus a type, or a type that we need to parse from the body. So for example, this job service, how do we know that this job service is should be resolved from the DI, or if this is actually it's a type that needs to be parsed out of the request body in your application? There was like some subtleties we had to figure out there. Anywho,
we've had a few questions.
Yes, sorry, I realized I dumped a lot of information on folks. I will take some questions now.
Well, one thing that comes up, and some of this is, like, so this that you've got on the screen right now is a good example. Mm-hmm. We've got a lot of nested ifs and people asking, like, are there other ways? Could you use switch expressions or other things there?
Maybe, but I honestly think the ifs are a little bit easier to read. I will admit that one thing we could do a little bit better is document these heuristics a little bit more of, like, there are certain types that we will explicitly bind directly, like HTTP context and cancellation tokens. We bind directly, and kind of all of those rules I was talking about how we will respect if you explicitly annotate something with an attribute to define its binding source, and then otherwise have these like funky things where we, not funky, these rules that we think make sense for binding from either the route or the query or the body or as a service. So I think for this, if statements make sense, it does look a little bit chaotic if you're approaching it for the first time. I think documentation, some more inline code docs would definitely help us here. But it's not so straightforward that just a switch statement would like do the trick. There's kind of, conditions and then sub-conditions within those. For example, if something is has a try parse method that we could resolve from either a route parameter or a query parameter, we have to kind of treat that differently depending on whether or not the parameter name actually appears in the route template and things like that. So if statements do make sense here, because it's not, I think it's a deeper level conditionals that you can't just do with a switch.
Oops, there was a...
But I mean, yeah, it is open source. So, I mean, if you can come up with something cleaner, feel free to give it a shot. Also, another thing about this RequestDelegateFactory type is it has a public create method, which, since this is like the deep dive, we can talk about a little bit. So, like, say that you want to take like map post, map get style delegates, but you don't want to call map get or map post. Maybe you want to do like minimal route handlers in like a controller like class. I mean, we wouldn't do that because that'd be way too confusing. But like, you could maybe.
Yeah. Yeah. So I think you're saying, Stefan, is if I was feeling particularly wild, I could do something like this, and then have my handler here. And it would do the thing. And I can invoke this anywhere, not just via.
Right, yeah, it basically spits out a request delegate, so you can use it like in general middleware and all that.
Okay. Cool. Let me see. There's a
any other questions?
Yep, just a few, and we're getting close to the end of our time. We've got a show starting at 11:30. So, any plans to use source generators for the OpenAPI JSON?
For the OpenAPI JSON,
or just just in general, more source generator use.
We have talked about it, Stefan, specifically for all of this kind of expression tree generation that we do in the RequestDelegateFactory. I think we landed on not pursuing it, but I believe you know a lot more about this. By the way, this is the code that we end up generating for when we try and, process your parameters from wherever they're sourced at. We've talked about it, but there are some like pros and cons that we were weighing out.
Okay. Let me see. There's a general question, and this is just a representative one, but what is Swagger? What's Swashbuckle? Like what's OpenAPI?
Yes. So OpenAPI is the specification for documenting APIs. It is generic and is used across all programming languages and API technologies. Swagger is the tooling for working with that specification. So Swagger is what provides the ecosystem of tools that generate OpenAPI definitions. It also has the UI that I just showed. Swagger also exists across multiple programming languages. So the Swagger UI is just a JavaScript application, JavaScript, HTML, and usually different frameworks, whether it's like .NET via Swashbuckle or Python, will have middlewares and handlers for serving the Swagger UI out of your application. So OpenAPI specification, Swagger, tools for working with the specification. And then within the .NET ecosystem, we have ASP.NET Core, which is what you use to write your APIs. Mm-hmm. We have the API Explorer, which is a concept that exists in ASP.NET Core for generating intermediary representations of the types of data that your APIs take in and spit out. And then there's ecosystem libraries like Swashbuckle and NSwag that look at that intermediary data and spit out the official OpenAPI spec definitions.
Okay.
It's a lot of different things balancing together, but it's kind of pretty cool that it all somehow lands. It's like the triple axle of API generation.
We'll need to update it, but I'll post. We did a blog post series too, covering a lot of like OpenAPI and stuff like that last February. Brady and I did on the .NET blog, and that covered some of those terms and tools. Some questions on versioning. Is it possible to add versioning with minimal APIs?
Yes. So I think we've got an issue tracking better support for the API versioning library that we're looking to tackle in .NET 7. Probably doing this by supporting like extension methods on the route handler. So similar to what you do with something like that. And another thing that's kind of analogous to supporting versioning is we're looking at supporting route handler groups, essentially. So the idea is that you would be able to have all of the map action definitions that you see associated with this jobs endpoint in one group, and you can kind of annotate and manage that group together. So I think of those as two kind of related things we're looking to pursue to make versioning a little bit better in .NET 7.
Okay. One last one, and then we'll go to wrap up. Is there a way to display all the routes in a minimal API? So I think an example here is the Swagger UI that you've shown.
Yes. Yeah. So this is the Swagger UI. You could definitely use this to display all of the routes. This is the JSON. This is the official OpenAPI specification compliant JSON that's produced that says here are your routes, and their unique identifiers, what types of responses they produce. So I think those two things exist if you'd like to kind of see all of the routes in your API. And of course, there's nothing stopping you from writing your kind of own middleware to examine them, or just using this.
Yeah,
I hope that was helpful.
Most people, I'd recommend using the Swagger. You can inject an IEnumerable of endpoint data source service, which is like the lowest level thing. But I think you lose out on all that work done by the endpoints, metadata provider that Safia was just showing you. And I forgot like 3 words in that class name, but
yeah, it's the endpoint metadata API description provider.
There you go. Okay. I think I picked that name too. I'm not sure. But yeah, even I can't remember it. So
well, okay, so we should wrap up. We've got another show starting in a few minutes. We've got VS Toolbox. What do you, any kind of like, as people are looking forward to .NET 7 and keeping up to date with minimal APIs, where should they be looking?
GitHub is the place to be. I think I've referenced it a little bit while I was taking a look, or while I was talking about kind of some of the future improvements we want to make. We've already kind of started out identifying some of the things we want to work on for .NET 7, and you can use our milestones in the repo to see what we're queuing up and actively working on and stuff like that. If you're interested in the OpenAPI stuff, I've actually got an epic that I'm drafted on GitHub that tracks all that work. The endpoint filter stuff that I was talking about earlier, there's also an issue for that. So GitHub is where we are at.
Okay, awesome. Just a sec. I'm sharing the info in the chat. So yeah, you can go to live.net or just on these channels. So we've got VS Toolbox next. Thank you so much. This is really super info, and it's great to go a little bit deeper than what we got to go over at .NET Conf. So.
Yeah, yeah, I had a lot of fun taking you down into the framework. Hopefully it was informative, and who knows, maybe we'll get a chance to continue the deep dive at another one of these. I think that would kind of be pretty fun to do.
Absolutely.
We could probably spend an hour on the RequestDelegateFactory. So.
All right, awesome. Okay, well, thanks a bunch.
Next to me, Standup, we write it as a Roslyn source generator, right?
Oh my God.
All right.
Okay.
See you, everyone.